Okay, guys, the whole goal of showing you how to operate on complex expressions was so that you can understand that you can solve quadratic equations that have complex solutions. So we're going to jump right into it. So for example, let's say we have an equation like 3 times 2x minus 1 squared plus 27 equals to 0. You can actually solve this by finding using the square root method. So here it would be um 3 times 2x minus 1 squared equals to negative 27. I'll divide both by 3 to get rid of that factor 3. So I have 2x minus 1 squared equals to negative 9. Now I can find the square root of both sides, right? And notice that I have a square root of a negative number. I have imaginary number. This allows you to, the complex numbers allows you to have solutions or to solve quadratic equations with no real solutions. So here we have 2x minus 1 is equal to, ta-da, 3i. Yep. Remember, because this is actually negative 1, square root of negative 1 times the square root of 9, which is I3 or 3i, right? So I'll add 1 to both sides. Okay. And we're still using the same rule. I'm sorry. We're still using the plus and minus rule. Add 1 to both sides. So we have 2x is equal to plus and minus 3i plus 1. Divide both sides by 2, which means every term is getting divided by 2. So x now, remember we have to put our constant first, is equal to a half plus and minus 3 halves I. And you can set that up as two separate solutions if you choose. It's a half plus 3 halves I. And then it's so x is two solution. Then it's a half minus 3 halves I. Alrighty, this is better. I prefer this. Let's try another one. So here is one where we can solve a quadratic equation using square roots with complex solution. And here's another possible one. You can have it in the form as we know it in its traditional trinomial form equals to 0. And whenever you see it has no real solution, you could apply the quadratic formula and end up with complex numbers. That's fine. So remember the formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And all we're simply doing is plugging in our coefficients. So here my a is 1, right? My coefficient of the first term is 1. My b, coefficient of the second term, is 2. And my constant term is 13. Okay, and that's correct because the equation is set equal to 0. And then it's just a matter of plug and play. So I have my negative b plus or minus the square root of b squared, which is 2 squared, minus 4 times 1 times 13. Okay, all over 2a, which is 1. So let's just take our time here. Prone to mistake if we kind of rush it. So this is actually negative 2 plus or minus the square root of 4 minus, what is that, 52? All over 2, right? All right, let's make sure we get some space. I'll take it up here. So let's see, from here to here, what do I have? 2 plus and minus the square root of negative 48 over 2. All right. And here I can break up my negative 48 into 16 and 3. So this is 2, negative 2, plus or minus the square root of negative 1 times the square root of 16 times the square root of 3. You see what I did there, right? Over 2. Just breaking it down. If you have hindsight, if you could see a bigger step to the solution before the end, that's no problem. But just make sure you show work on an exam. So here we go. We have negative 2 plus and minus. This is actually 4i, right? 4i root 3 over 2. And now we can try to simplify this fraction. Remember, it tells you how many terms I have in the numerator and they share a common denominator, and I'm sure it can be simplified. So it looks like I have negative 2 over 2 plus and minus 4I root 3 over 2. So here I'm left with negative 1 plus and minus, right? 2 can go into 4 twice. That's 2I. 2I root 3. Or we can actually use 2 and root 3 as a constant, and it can be written as negative 1 plus and minus 2 root 3I. All right, guys, that's just a snippet of solving equations that to let you know that there's a possibility you can have complex numbers as you evolve in solving quadratic equations.